Welcome to Spring LIB.
So here in this problem we are given that Q is equals to 1 times 10 to the power minus 8 coulomb, and the distance A we are given as 5 centimeter, which can be written as 5 times 10 to the power minus 2 meter. Now we have to calculate the magnitude and the direction of the electric field at the center. That means at this point we have to calculate. Now first of all we'll be calculating the distance of the point charges from the center. That is this distance r, and this distance would be same for each and every charge. So r would be equals to a over root 2, and a we have 5 times 10 to the power minus 2 meter divided by root 2, and it would be equals to 3.53 times 10 to the power minus 2 meter. Now next we will be calculating the electric field at point C due to plus Q charge, and the direction would be like this, and this angle would be 45 degree. So E1 would be equals to 1 by 4 pi epsilon naught Q over R square times cosine 45 I cap minus sine 45 j cap. Now we're going to put the values. So 1 over 4 pi epsilon naught is equals to 9 times 10 to the power 9 is a constant, times Q we have this much, so 10 to the power minus 8 coulomb, divided by R square we have this much, so 3.53 times 10 to the power minus 2 meter whole square, times cosine 45 is 1 over root 2 I cap minus 1 over root 2 j cap. So we're going to simplify this and we'll get 5.091 I cap minus 5.091 j cap. Now next we will be calculating the electric field at point C due to plus 2q charge. So this is for plus 2q, and the direction would be like this, and here also the angle would be 45 degree. So E2 would be equals to 1 over 4 pi epsilon naught times, here it will come 2q over r square, and multiplied with minus cosine 45 I cap plus sine 45 j cap. Now I'm going to put the values. So this value 1 over 4 pi epsilon naught is 9 times 10 to the power 9, multiplied with 2 times q we have this much, so 10 to the power minus 8 divided by r square is this much, so 3.53 times 10 to the power minus 2 meter whole square, and cosine 45 is 1 over root 2, so minus 1 over root 2 I cap plus 1 over root 2 j cap. Now we're going to simplify this and we'll get 10.182 I cap plus, sorry, here it will come one negative sign would be there, plus 10.182 j cap. Now next we will be calculating the electric field at point C due to minus q charge. So this is due to minus q charge, and the direction would be like this, and this angle would also be 45 degree. So it would be E3 is equals to 1 by 4 pi epsilon naught q over r square times minus cosine 45 I cap minus sine 45 I cap j cap, sorry. Now we can put the values. So here we'll get 9 times 10 to the power 9, and q we have 10 to the power minus 8 divided by r square we have this much, so 3.53 times 10 to the power minus 2 whole square, multiplied with cosine, this is minus cosine 45 is 1 over root 2, so minus 1 over root 2 I cap minus 1 over root 2 j cap. Now we're going to simplify this and we'll get 5.091 I cap minus 5.091 j cap. Now next I will be calculating the electric field due to minus 2q charge. So this is due to minus 2q, and the direction would be like this, and this angle would be 45 degree. Now, so E4 would be equals to 1 over 4 pi epsilon naught 2q over r square times cosine 45 degree I cap plus sine 45 degree j cap. Now I can put the values, so we'll get 9 times 10 to the power 9 multiplied with 2q, we have this much, so 10 to the power minus 8 coulomb, divided by r square, we have 3.53 times 10 to the power minus 2 meter whole square, and cosine 45 is 1 over root 2 I cap plus 1 over root 2 j cap. Now we're going to simplify this and we'll get 10.182 I cap plus 10.182 j cap. So the total electric field, or the net electric field, would be E is equals to E1 plus E2 plus E3 plus E4. Now let us put the values here. So we'll get EI, so E1 we have calculated as 5.091 I cap minus, this is 5.091 j cap. Now plus E2. So E2 we have minus 10.182 I cap plus 10.182 j cap plus E3. So E3 we have minus 5.091 I cap minus 5.091 j cap plus E4 we have 10.182 I cap plus 10.182 j cap. Now we're going to simplify this and we'll get 5.091 times 2 j cap, and that would be equals to 10.182 j cap. So this is the net electric field, and the direction would be 90 degree from the positive x-axis. So alpha, we can say it would be 90 degree from positive x-axis. So I hope you have understood the problem. Thank you.